Yeah. This is a follow-up from yesterday's lesson. You've been dealing with the position graph and realising that when you calculate the gradient, that tells you the velocity at a point. If you calculate the gradient of the velocity, it actually gives you the acceleration graph. Now, these acceleration graphs are a little impossible because there's no way to just shut off acceleration. It never just goes from having something to being nothing. It always actually will go somewhat in a curve or a line to zero and then change to something else. This sort of change here implies an infinite amount of energy has been used. So this isn't true, but a lot of situations get very close to this. Um, this sharp edge is what leads to a sharp corner on the graph here. So the velocity graph is a little bit wrong as well. So what you're going to be asked to do is, the worksheet, there's a number of position time graphs. And by playing with the velocity and the position graph, I haven't actually asked you to change the position at any time. It stays the same. This blue dot never gets asked to move. But I'd like you to try and work out how to produce some of these graphs. What must happen? So I'm just going to play with the tool so you can see what goes on and how we're going to talk about it. To start with, I'm just going to get rid of the acceleration. We'll talk about what's happening with acceleration afterwards. So let's start off with the velocity, all of it at zero at the start, and then a bit of a positive velocity and a very positive velocity. I'll talk about negative in a minute. So we start off with no displacement and no velocity. No velocity says don't move. So the position isn't moving, saying that we will have zero velocity along this point. Again, the next section, there's no motion, so there's no velocity. The next slot though, what you notice is it starts off with no velocity, so no velocity here. But then gradually it starts building up, building up, building up, and the speed, as it gets steeper, the speed gets more. So starts off with nothing and then builds up for the velocity to increase. Okay, so this is an increased velocity. Then as we go from that point, it increases and it increases quicker. Now it's hard to see that apart from if you turned around and thought if it continued, it would have if it had continued with a velocity like that, it would have continued up to about here. If it only increased a little bit, it would have increased a bit more. So this much steeper line makes it steepen a lot quicker, a little hard to see. So it's that sort of reasoning you put into what's happening. Let's think about how the acceleration comes about. This bit I'm really expecting you to more or less go, what's it doing? But let's look at no change in velocity. That means zero acceleration in that first time period. No change in velocity, zero acceleration. Then I've got a constant increase in velocity. It's sloping up. That means I have a constant acceleration. And then when I go to a much quicker increase in velocity, the acceleration is much quicker. Okay, so that's how all of these bits work. And hide that way. Let's see what happens if I put a negative velocity in. So it starts off now very zero, close to zero. But then the negative velocity means we're moving backwards, but moving backwards gradually quicker, 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 quicker. At this point, we're continuing with the same velocity backwards at the moment, but gradually that reduces. So we're going backwards and then it starts slowing up backwards. So it flattens off towards zero at this point. So we've got a zero velocity at this point. Anywhere this goes flat, you have a zero velocity. And then it builds up again from there, increasing all the way to this point, which is an acceleration of 1 apparently, and then increases again for an acceleration going up, and now it's up to here. Okay, I'm not asking you to put numbers to it. I'm looking for the interpretation. Just have a look at the acceleration. Start off with a negative acceleration. The velocity is saying try and go backwards. If I change the displacement, it means I am coming back towards the start, and then when I get to the start, accelerate. We're assuming time and displacement 0 is a start point. So your task is to play with this and try and create a number of these graphs. The last, this one is a situation you should be familiar with from science. You start off with a particle, it moves up, goes to the highest point, and then continues on falling downwards, 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 downwards. You might know what that is. These two graphs are actually very closely linked. Their velocities graphs follow the same profile, but their position is slightly different. That means that one of them, the position versus time, it stays around the same point. If you look at its velocity, it should tell you why that's always staying around one value. If you look at the value going forwards, backwards, it should imply to you that overall you're going to go nowhere. The second one, it's a similar graph to the one above, but this one has an average movement. So on average, this one goes nowhere. On average, this one moves forward. So what is it in there that's saying that? And that's the answer to question 7. Okay, so there you go. It's an investigation. Play with the software, try and see, can you create the position time graphs? So take your time, play about with them, just see what's happening first, and then try and create the situations.